Lesson 8.7 is about finding the rational roots of polynomial equations. So roots, again, we know that that means it's a solution to the equation. We know that that means it's a zero to the equation. Those are all synonyms. So if we're talking about a polynomial, if I just sketch some, basic polynomial shape, let's say it's something like this, the roots or solutions are where it intersects the x-axis. So in this case, the picture I drew would have 4 roots. So what we're going to do is use this, what's called the rational root theorem, in order to find all of those roots that would be rational, meaning you could write it as a ratio, a fraction. So here's what the rational root theorem says. I'll read from here. So it says, suppose that a polynomial equation with integral coefficients has root p over q. See, it's rational, it's a fraction. It says where p and q are relatively prime integers, then p must be a factor of the constant term of the polynomial, and q must be the factor of the coefficient of the highest degree term. So that last sentence was the most important. What this whole idea of p over q does is let us generate a list of all of the possible roots. So that way we can choose from that list to help us narrow down and find the roots of the equation. So we'll be writing these fractions of possibilities. All of the possible values of p are the factors of the constant term in the polynomial, and q are all the factors of the leading coefficient. So here's an example. The directions will just say find any rational roots, and then go ahead and solve it completely. So to come up with a list of the rational roots, we're going to use the rational root theorem, which says all the possibilities are going to be p over q. P is all the factors of the constant term. In this case, that's 6. So thinking about all of the factors of 6, we have 1 and 6 and 2 and 3, and then we could have, either positive or negative of all those values. So the way I'm going to write it is plus or minus 1, 2, 3, or 6. Those are all the possible factors of the constant term over the factors of the leading coefficient, or the highest degree term. So that's here, x cubed. It has a coefficient of 1. So the only factors of 1 are positive and negative 1. So what we really have then is each of these numerators over the denominator. So 1 divided by 1 will still be 1, 2 over 1 is 2, 3 over 1 is 3, 6 over 1. So really we can just rewrite this as plus or minus 1, 2, 3, 6. Okay, so those are all of the possible rational roots. We know if something is a root of a polynomial, we can synthetically divide it and get a remainder of 0. It really wouldn't be that fun to try all 8 of those to figure out which ones give a remainder of 0. So in this class, we're going to let you use a little hint, and that is put this equation in your graphing calculator. So I'm not going to be able to quite show that on here, but I'll write down what I'm doing. So in the graphing calc with the y equals button, you're going to enter x cubed minus 7x plus 6, and then you're going to hit the graph button. And you're going to look at the picture that you see. So I'll make a rough sketch here. So this is our xy axis. This looks something along the lines of this. That's what that polynomial looks like. So what we're trying to solve for are the roots, so where it hits the x-axis. So that happens here, here, and here. So we have all of these possibilities, and we can see a visual of the roots we're actually looking for, so that lets us narrow it down. So let's say we're going to try this one first. If I look at my graphing calculator, that's at the point -3, which was also one of my possible rational roots. So I'm going to synthetically divide -3, and I should get a remainder of 0. So I'm going to take all my coefficients, x cubed, there's no x squared, -7x, and 6. So let's synthetically divide. So we multiply and add, multiply, add, multiply, add. If you don't know what I just did there, go ahead and go back to lesson 8.4 and rewatch that video. So since we did get a remainder of 0, that means that this is a root. So we can write the factored polynomial as x plus 3 times what's left here. So x plus 3, because if 3 is a root, we set this equal to 0, we get negative 3. And then this is the remaining polynomial here. So we get x squared minus 3x plus 2. So what we've done with all this work here, is just factor this polynomial one step further. Now, we could synthetically divide again, but at the point where you get to a quadratic here, we know how to factor those. So what we're going to do is just go ahead and factor that without synthetic division and say, okay, well, I know x times x will give me x squared, 2 times 1 will give me 2, and I want that to add to negative 3, so both minus signs. So solving this by setting each term equal to 0, we're going to get negative 3. We know that. That was the root that we chose. We're going to get 1, and we'll get 2. So we've solved it completely for all 3 roots, which you can clearly see in this picture. This one root here, another root, and another root. So they're at negative 3, 1, and 2. All right, let's try another one. Same directions. Let's just get a little bit different constants and leading coefficients in this case. So the first thing we do is use the rational root theorem to just generate a list of all of the possibilities. So we look at the factors of our constant, which is negative 5. So that'll be positive and negative 1 or positive and negative 5. Then we look at all the factors of our leading coefficient, or our highest degree. So that'll be 1 and 2. So plus or minus 1, plus or minus 2. So what we have is, 1 and 5 both being divided by 1, and then 1 and 5 being divided by 2. So I'm going to rewrite it as just plus or minus 1. That's if I divide the 1 by 1. Plus or minus 5. That's 5 divided by 1. Now do the same thing with the 2. So plus or minus, it's going to be 1/2, and plus or minus 5/2. So those are all of my options. I could synthetically divide all of them and try to find a remainder of 0. But as I mentioned in this class, we can use that graphing calculator to kind of give us a hint, just so that we're not trying 8 different options. So if I put this in my graphing calculator, which I wrote the buttons down on the first slide, you can look back at that, or you can come see me if you're struggling. But it looks something like this. So we see here that there is a root happening right here. And if I look in my calculator, that's happening before 1, so I'm thinking I'm going to try positive 1/2. So let's see if that's right. So I'm going to synthetically divide 1/2 from the polynomial given. So 2, 7, 6, negative 5. So I drop down my 2, multiply. Again, if you don't know what I'm doing in this step, please go back and watch the previous video on synthetic division. Okay, I do get a remainder of 0, so that means that 1/2 is a root. We selected that root correctly. So let's write the factored polynomial then. If 1/2 is a root, then x minus 1/2 is a binomial in the factored form of that polynomial. Then what's left is what's remaining from our synthetic division here. So that's going to be 2x squared plus 8x plus 10 equals 0. So at this point, now that this is a quadratic, we can just solve this with any of the quadratic methods we know. We're going to try to factor it. If it doesn't factor, then we can just use the quadratic formula. And that's what I'm thinking is going to happen, because there looks like there's only one root here. So if I'm going to get any more, they better be imaginary, because then I won't actually see them intersecting this line. So that's why I'm going to choose to solve this using the quadratic formula. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to quite show all my work for this, but I'll do some of the reduction here. we're going to get -4 plus or minus the square root of -4 over 2. So if you have a negative under a radical, that means it's imaginary. So this is -4 plus or minus 2I over 2, or -2 plus or minus I. So there's two roots. Those are imaginary. And then we have one real root, which came from over here. If I set x minus 1/2 equal to 0, I get 1/2. So this makes sense with the picture that I've drawn. I'll rewrite this all. So we have 1/2 as a root. Then we have -2 plus or minus I as our other two roots, for a total of 3, only one being real. Okay, same directions, but this time notice that this is a 4th degree polynomial. What that means basically is we're going to need to do that synthetic division step one more time. In order to get down to a quadratic, we can just, factor a quadratic formula. Okay, but everything starts out the same. We're going to do rational root theorem. So all of the factors of the constant, which are -6 here, so that's plus or minus 1, 2, 3, and 6, all over the factors of the leading coefficient, or the highest degree term, which is just plus or minus 1. So dividing the numerator by 1 isn't going to change any of these terms, so I'm just going to rewrite it like this. So those are all of our possibilities. Wouldn't be too fun to try to synthetically divide all 8 of these and see which one's going to work. So go ahead and use your calculator just to get a visual and an idea of which roots you're going to try. Okay, so if we do that, we're going to see a graph that looks like this. Exaggerated some of those a little bit. But we have roots here, 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 and here. Okay, so I would look at my graphing calculator and pick one of those values that looks like it's one of my possible roots here. So the first one that I see that I'm going to try is this first value here is at -1. So I'm going to synthetically divide that from the original polynomial. So the coefficients are 1, 3, -1, -9, and -6. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, that's positive, add. So it is a root because it divides evenly. And what this means is we have the factored polynomial x plus 1, because our root is -1, and then what's left over from this synthetic division right here. So that's x cubed, 1 degree less, plus 2x squared minus 3x minus 6. So that's where we're at right now, but now because this is a cubic, we can't just use the quadratic formula or factoring in order to solve this. So basically we need to pick another root. So I'm going to look back at my picture. I see that this value here is -2. So that's what I'm going to try next. And now when I synthetically divide it, I'm going to synthetically divide it from this cubic equation that we have right here to factor that one further. So I have 1, 2, -3, -6. So bring this down, and you know the drill here, and we get a 0 as a remainder again. So that means we have the polynomial. First of all, that x plus 1. Now that we know -2 is a root, that means x plus 2. And then we have what's left over from this synthetic division, which is x squared minus 3. Now we can solve this by just setting all 3 terms equal to 0. I'm going to move it up a little. So if I set x plus 1 equal to 0, we know we get -1. That was one of the roots we tested. If I set x plus 2 equal to 0, we know we get -2. That was another root. Now to get our last root, we'll set x squared minus 3 equal to 0. So I'll add 3 to the other side, and then take the square root of both sides, and I'll get plus or minus √3, which makes sense to me because I see that, the 2 roots I already looked at were this -1 and -2, and I still have this other negative root and this other positive root. So that's a total of 4 roots. So I'll rewrite them all together here. So we have -2, -1, and plus or minus root 3. And there it is. We solved it completely. All right, so the homework for lesson 8.7 is posted up on Schoology, so go ahead and take a look at that.